Hey guys, welcome to another interesting video in this AI trail. And today, as you see on the screen, we are going to cover a really interesting topic that confuses many, right? Absolutely, because of the name, it is the confusion matrix, right? So this is a really crucial topic, especially for interviews, right? Because many of the interview questions on traditional and classical machine learning, right? They're based on this. The reason being that it's one of the strongest evaluation metrics for classification algorithms, right? So in this video, we are going to clear all confusion related to the confusion matrix. So by the end of this video, I'm sure that none of you are going to be confused whenever we talk about the confusion matrix, right? So that's the intention. So with this intention, let's move ahead. So let's take the whiteboard and discuss a scenario, right, to get the confusion matrix. Okay. So let's say you have a basket of fruits, all right? Let's say you have a basket of fruits, and in that basket, let's say you have 5 apples, right? And you also have 5 mangoes, all right? And these are the 5 mangoes, okay? Okay. So now what you're going to do is you have built a machine learning model, right? Let's say it's a machine learning model which has been fitted inside a camera, right? And the job of the model, I mean, the job of that machine is basically to capture the image of any fruit and to predict whether the fruit is an apple or a mango, right? That's the job of the model. So the job of the model is to correctly classify a fruit as an apple or a mango based on the image that the camera of the machine captures, okay? So the model is fitted inside the machine, all right? Okay, so let's say, now why is the scenario relevant? Because like some apples might be light in color, they might be mistaken to be mangoes, and some mangoes might be reddish in color, they might be mistaken to be apples, right? So that's why we have built this algorithm that correctly classifies whether a fruit is an apple or a mango, okay, based on observation in the image, right? So let's say if a fruit is, let's say this machine is basically meant for capturing the mangoes, all right? That's the job of the machine, is to capture the mangoes. So if a fruit is predicted as a mango, then we call it a positive prediction, right? And if it's predicted as an apple, we call it a negative prediction, all right? So just keep this convention in mind. Again, positive and negative, it's all a relative term that depends on which side of the story you're into, right? So for our story, we say mango is a positive prediction and apple is a negative prediction, okay? So let's say once you use the model, right, to classify the fruits, and if you run the model on all these fruits, right, all the 10 fruits, then let's say these are the results, right? In the predicted, let's say like a couple of these mangoes, 1 and 2, are incorrectly predicted as apples, right? And few of these apples, let's say 1, 2, and 3, few of these apples are incorrectly classified as mangoes, all right? That's the scenario here. Okay, so rest of the mangoes are correctly classified as mangoes. Okay, and obviously rest of the apples are correctly classified as apples, right? Okay, so let's segregate this. So this is a line that segregates the actuals from the predictions, right? So let's say these are the actuals. These are the predictions. Okay, all right. So now let's divide this as well into apples and mangoes, all right? So now we come to the first metric, right, in the evaluation metrics. So the first metric is called as recall, okay? What is recall? Let's say recall for the mangoes is basically the total number of mangoes which we already had. That comes in the denominator, which is 5. And the total number of mangoes correctly classified as mangoes, right? So like this mango is correctly classified as a mango. This one is correctly classified as a mango. This one is correctly classified as a mango. But these two have been classified incorrectly as apples. So the number of mangoes correctly classified as mangoes out of the total ones in the basket, that is 3, right? So 3 by 5. So the recall is 3 by 5. That is 60%, right? Okay. And then similarly for the apples, right? Recall for the apples is how much? The total number of apples in the basket goes in the denominator. Okay. That is 1, 2, 3, 4, 5, all right? And the total number of apples correctly classified as apples, that is 1 and 2, right? So 2 divided by 5. Okay. Equals 40%, right? Okay. Now this is the value of the recall for the individual classes, right? Okay. Now, there's another metric that tells you how much you can trust the model, right? And that metric is called as precision. So precision for the mangoes is basically given by, now here what you have to look at is the total number of items which have been predicted to be mangoes, right? That is 1, 2, 3, 4, 5, 6. These are the predictions made by the machine that tells you that these are mangoes. However, how many of these are actually mangoes? It's only 1, 2, and 3, right? The remaining ones are apples, which have been incorrectly classified as mangoes. So the precision for the mangoes is basically in the denominator, you're going to have the total number of items classified as mangoes, which is 6. And the numerator, you have 1, 2, 3, which is 3. Actual mangoes, right? This comes out to be 50%. Okay. So precision means how much can you trust the predictions of the model. Okay. So you can trust this model only with a value of 50%. Okay. Similarly, precision for the apples is given by the total items predicted as apples. That is 1, 2, 3, and 4, right? However, out of these, just these two are actually apples, right? The remaining ones are actually mangoes, incorrectly predicted as apples, right? So what's precision going to be for apples? The total number of items predicted as apples, that's in a denominator, that is 4, out of which just these two are actually apples, right? So that becomes 2 by 4, which is again 50%. Okay. So in this way, we have obtained the precision and the recall values for the individual classes in the basket, right? Okay. Now let's come to this concept here where we have made a convention, okay? Because in the real world, we are actually interested in correctly predicting only one of the classes, right? Let's say we have a scenario where we are building a cancer detection model, or let's say a COVID test, right? So here we are predominantly interested only in one class, like whether a person has a cancer, right? Or whether a person has COVID. We aren't too keen about the other class, whether a person doesn't have cancer or doesn't have COVID, right? We are more keen about the positive prediction here. Does that make sense? So in the real world, what we do is we focus only on one of the classes and we try to express all these metrics in terms of the positive class. Okay. So if you look at this thing, right, like if we come back to this convention that mangoes is positive and Apple prediction is a negative prediction. So how do you represent the recall in terms of the positive prediction? Like mangoes is positive and apples is negative, right? So recall is given by the number of mangoes correctly classified as mangoes that comes in the numerator, right? So they are called as the true positives. A mango prediction is positive, right? So a mango correctly classified as a mango becomes a true positive, right? And a mango incorrectly classified as an apple becomes a false negative. Does that make sense? Right? So the recall is going to be the true positives divided by the total values, right? What are the total values? The true positives, which is 1, 2, 3, plus the false negatives, that is 2. So true positive divided by true positive plus false negative, right? That is a recall, okay? Keeping into account this convention that mangoes is positive and apples is negative. Suppose we had the reverse convention. Still, the formula would have been the same, but we would have used the numbers from this side, right? Instead of this side, okay? Similarly, the precision, right? Now the precision, so let's erase this now. Let's erase this to give space for confusion matrix. Okay. So the precision for mangoes, right? So you can just see the precision. Is given by what is the precision? The total number of items, right, which have been predicted by the model has mangoes. They'll be in the denominator, right? Okay, but in the numerator, you have only the actual items which are actually mangoes, which are the true positives, right? And in the denominator, you have the true positives plus these items which are actually negatives but classified as positives. So they are called as false positives. Okay, so these are the true positives, right? So true positive plus false positive, right? That's the precision. Okay. And there's another metric called as accuracy that tells you the overall performance of the model, right? So accuracy is given by true positive plus true negative divided by true positive plus false positive plus true negative plus false negative. So the denominator is the total number of predictions. In this case, it's the total value. That is 5 plus 5, that is 10. And this are only the true values. That is true positive, 1, 2, 3, plus true negative, that is 1, 2. Okay, that's the accuracy, the overall performance of the model. Okay, but in certain cases, like if you have a class imbalance, accuracy alone is not sufficient. So that's why you require the recall and the precision, right? Okay. So now let's plot the confusion matrix here. So what's the confusion matrix now? It's basically like a diagram that shows you the distribution of different values, right? The predictions and the actuals. So it's usually drawn like this, like for a two-class classification problem, like we have it right now. We just have two classes, right? One is the positive class, that's the mangoes. One is the negative class, that's the apples. So this is always the actual values, right? Look, the horizontals are always the actual values, okay? And the verticals are the predicted values, right? So this is positive p negative n, positive p negative n, okay? So something that is actually positive and also predicted to be positive, that's called as a true positive, okay? So in this case, actually positive mango and predicted to be positive mango. Actually positive, predicted positive. Actually positive, predicted positive, right? That's a true positive. And similarly, on the other side, something which is actually negative and predicted negative, that is a true negative. Actual negative, predicted negative. So that's a true negative. Similarly, something which is actually positive but predicted to be negative, that's a false negative, right? Positive but predicted negative. Positive but predicted negative. That's a false negative. And something which is actually negative but predicted positive. That's a false positive. Negative but predicted positive. Negative but predicted positive. That's a false positive. Yeah. So now if you want to count the values of each of these classes, right? How many true positives do we have? Looking at the results, true positives is basically mangoes classified as mangoes, right? Mango, 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 mango 2, mango, mango 3. So total three true positives. How many false negatives? False negatives is the total number of mangoes classified as apples, right? Something which is not negative but predicted as negative is something which is called as a false negative, right? Something which is actually positive but predicted as a negative is a false negative. So how many such values do we have? Mango in reality, but apple in prediction. Mango in reality, apple in prediction. So total two values. Okay. And then how many false positives? Okay. What is a false positive? Something which is negative in reality, but predicted to be a positive by the model is a false positive, right? So how many such? Something which is an apple in reality, but predicted to be a mango. So you have one case here, another case here, and another case here. Okay, so total three. Three false positives. How many true negatives? Something which is a negative in reality and also predicted to be a negative. So something which is an apple in reality and predicted to be an apple. An apple in reality and predicted to be an apple. So like this, we have two cases, right? One and two. Okay, I hope you can see the fruits now because we have done a lot of process. Okay. So if you plug in these values, right, into the respective formulae over here, okay. So what is recall? For recall, you should always look at this particular line, right? Is the true positive divided by the sum total of true positive plus false negative, right? You plug in the values, you get it. Is basically 3 divided by p plus 2, right? That's 3 divided by 5, that is 60%. And what is precision here? It's true positive. Always look at this particular thing for precision, okay? So all your formulae are basically over here and here, okay? Precision is true positive divided by true positive plus false positive. So what is the true positive here? If you plug in the values, 3 divided by, sorry, true positive is 3, right? 3 divided by 3 plus 3, that is 3 divided by 6. That is 50%, okay? So we have confirmed that the values basically match, right? So that's the confusion matrix for two class classification, right? Okay. Now suppose you have more than two classes, right? Like suppose you have like say a three class classification. Let's erase this. Let's say along with this, you also had an orange, right? Okay. Say along with this, you also had an orange. So the basket you also had like 5 oranges. Yeah. Or maybe let's draw this thing again. Let's say, let's take a new scenario here. Let's say that in your basket, you had, like, say, um, okay, this is your basket. Okay. And these are actuals in the basket. These are predictions. Okay. Let's divide this. So let's say you had 1, 2, 3, 4, 5 apples. Okay. And 1, 3, 4, 5 mangoes. Yeah. And 1, 2, 3, 4, 5 oranges. Okay. Right. Now let's say in these oranges, like, two of them are correctly predicted to be oranges, that is 1 and 2. Here you have like one incorrect, like two incorrect predictions. So oranges, yeah. Here, right? So the scene is clear, right? In the basket of apples, one of them is incorrectly predicted as an orange and one incorrectly as a mango. In the basket of mangoes, two of them are incorrectly predicted as oranges and one incorrectly as an apple. And in the basket of oranges, two of them are incorrectly predicted as mangoes and one as an apple, right? Okay. So these are the incorrect predictions. The rest, all the predictions are correct. Okay. So now here we again stick to the convention that a mango. So a mango is basically positive prediction. So positive, and apple or orange is negative. Okay. All right. So coming to the confusion matrix now, it's going to look like this, right? Yeah. So positive, negative, positive, negative. Okay. So positive and positive is true. So how many true positives do we have? Mango is positive, right? So 1 and 2. So just two true positives, right? So true positive equals 2. How many false negatives do we have? 1, 2, and 3, right? Okay. So false negative equals 3. Okay. Why? Because mango predicted as an orange, mango given as an apple, and mango given as an orange, right? So these are the false negatives. Okay. How many false positives do we have? 1, 2, and 3, right? So basically, an apple predicted as a mango is a false positive, and orange predicted as a mango is also a false positive, right? So total 3 false positive, yeah, equals 3. How many true negatives do we have? So what are true negatives here? Apple predicted as an apple, okay? And mango predicted as a mango. Okay, sorry. Apples predicted as an apple, okay? Orange predicted as an orange. Okay, that's the true negative. So 1, 2, 3, okay, 4, and 5, right? So true negative equals 5. Okay. But however, you see, like since it's a three-class classification problem, right? Like just having a 2 by 2 confusion matrix like this doesn't do the job in this case, right? Because you see, like this thing is also, you can say like an incorrect prediction, which is not being captured here, right? And this thing is also an incorrect prediction, right? Which is not being captured here, okay? So in case of these kinds of problems, right, rather than having a true positive and a true negative kind of a scenario, what you do is you actually represent the matrix in terms of the actual fruits, right? So here's how you do it. It's going to be a 3 by 3 matrix. Yeah. Yeah. So you have the actual apple, mango, orange, and the predicted apple, mango, and orange. Okay. So what is A and A? Actual apples, predicted apples. That is A and A, right? So that becomes 1 and 2, right? And 3, obviously. Number 3. Yeah. So that is 3. And for mangoes, so M and M, right? So actual mangoes, predicted mangoes, that's 1 and 2. That's 2. And actual orange, predicted orange, that is 1 and 2 again. So that is 2. Okay. The remaining values are basically all the incorrect predictions, right? So actual apples predicted to be mangoes, you have to put that value here. Actual apples, okay, predicted to be mangoes, that is only one case, so this becomes 1. Actual apples predicted to be orange, there's also one case here, right? Becomes 1. Okay, so this is done now. The apples basket is over. Note that this should sum up to the total values in the basket, right? So 3 plus 1 plus 1 should equal to the total values here. That is 5. Okay, so that equals correctly. So that's done. So here we have 2. So we need like 3 more values to fill, right? In this basket. The mangoes is the actual apples basket. It's the actual mangoes basket. So we already have 2 values filled here. So this value is going to be actual mangoes predicted as apples, right? Which is 1. That becomes 1. Obviously, this becomes 2, right? Okay, actual mangoes predicted as oranges, that is 1 and 2. Okay, so the mangoes basket is filled again. And then coming to the orange basket here. So we already have the value for actual oranges classified as oranges. Okay, and actual oranges classified as apples is this box, which is just one quantity here, right? And obviously this becomes 2, right? If you verify this box stands for actual oranges classified as a mango. Okay, which is 1 and 2. So that's correctly filled, okay? So this is the confusion matrix for a 3 by 3 classification, okay? And here, now depending upon like which quantity you want to call as positive or negative, you can basically define the matrix. Else, you can just simply define the matrix in terms of the individual classes, right? So like recall for orange, is basically, you look at the orange basket over here, right? Recall for orange is the number of oranges correctly classified as oranges, that's the numerator, divided by the total oranges that we had in the basket. That is 1 plus 2 plus 2. That is 5, right? So 2 by 5. Okay. Similarly, recall for mangoes is the mangoes classified as mangoes, that is 2. These are the true positives, mangoes, divided by, again, the total values in the basket, right? 1 plus 2 plus 2, that is 1 plus 2 plus 2. Okay, that is 2 by 5. So note that in the case of orange, these two becomes the false negatives, right? And in case of the mangoes, these two become the false negatives. These are the true positives. These are the true positives, okay? And recall for the apples are is the total apples correctly classified as apples, that is the true positives, divided by the total values in the basket, right? 3 plus 1 plus 1, that is 5. Okay. So this way, we understand the different metrics, that is recall and precision, and the confusion matrix as well, right? So precision is going to be calculated similarly, right? Like what is precision for apples? The total apples, like the total number of values predicted by the model as apples, okay, which is basically how much? What is that going to be? Is again is 3. The denominator, right? Precision. The denominator, you have the total values classified as apples, right? So apples classified as apples, and mangoes classified as apples, and oranges classified as apples, right? So 3 plus 1 plus 1. And the numerator has the actual true positives, that is the apples classified as apples. So it's again 3 by 5. Okay. That's the precision for apples. Okay. Yeah. So like coincidentally here we have like 5 apples in the predictions. Like 1, 2, 3. Well, we have 4 apples in the predictions. Okay. No, we have 5 apples, right? Like we have 1, 2, 3, 4, 5, and then 5 oranges. 1, 2, 3, 4, 5, and 5 mangoes. 1, 2, 3, 4, 5. Yeah. So we have 5 classes of each classification. So the denominator is the same in this case, coincidentally. Okay, that's fine. So in this way, we go about plotting the confusion matrix, right? Okay, so I hope this video has cleared your confusion on the confusion matrix, okay? If you have any questions, please feel free to type them in the comment box at the bottom. I'll be happy to, respond to your questions, okay? I hope this video has been useful, and for more such videos, please subscribe to the channel, The Learning Trail, and yeah, enjoy your learning. So with this, we end the video here, and I hope it's been useful. Happy learning and great luck with the studies. Thank you. Bye-bye.